What can you tell me about cosine? What's the biggest cosine can be?
1.
Has to be less than or equal to 1, do you agree? No matter what you plug in, right? Do you agree?
Yeah.
Okay. So what does it have to be greater than or equal to?
Negative.
Okay, so you know it has to be between that. Now that's for all values, right?
Mhm.
What about from 0 to 1? What is cosine of 0?
1.
And what's cosine of 1? You don't really know what it is, but it's stuck between these things. It's not bad. Okay, so you agree that that's true?
Mhm.
Yeah. If I multiplied everything by 3, does the statement still hold? Could I multiply everything in that inequality by 3? Is that okay if I wanted to? Could I multiply by pi by everything? Sure. Could I multiply by x?
Yes.
Yeah, you sure can. What about x squared? Okay, so do you agree that this is true? What about this? Do you agree with that?
Yeah.
Do you agree that that's true?
Yeah.
All I did was apply the golden rule of algebra, which says if you do one thing to one side, you have to do it to the other. Okay, so let's just think about this for a sec. We know that this middle value is always between negative x squared and x squared.
Mhm.
So if that's true, is this also true? What do you think about this?
Negative x squared, yes.
Negative, sorry, yeah, I got it, sorry. Is that correct?
Mhm.
Do you agree with that?
Yes.
Yeah, absolutely. Okay, well, what is this equal to? You can evaluate that. What is that? That is 1/3 x cubed from 0 to 1. What is that?
1/3.
So what have you now shown? The integral from 0 to 1 of x squared cosine x dx has to be less than or equal to what?
1/3.
You're done.
Oh my god.
You see what I mean? It's elegant. It's really cool. I took a class when I was studying, would be just to say that you know that cosine, no matter what you plug into cosine, x has to be less than or equal to 1, right? So e to the x cosine x has to be less than or equal to e to the x. So if you integrate both of these, what do you end up with? If you integrate this from 0 to 1 like this, what do you end up with? You end up with e minus 1. So you end up with this integral, which is what you wanted, is less than exactly what you wanted right there. That's great. Another way you can think about this, another way you can find upper bounds is the following. This is a picture you should try to keep in your head, kids. Let's say you had a function. Let's say that you had a function that went from, let's say it went from a to b. So you're looking at it from a to b, like this. Let's say the function's traveling, I want to spike it a little bit here. Up like this. Let's say that's the function. Let's say that this height right here, this height is y equals c. Got it right there? Let's say I asked you, and let's call this, I'm going to give you all terminology, let's call this, I don't know, f of x. That's the blue function. What is the upper bound of that integral? You know that that has to be less than or equal to what? You know it has, so I'm looking at this area right here. You know that that area right there has to be less than or equal to what? Yeah, exactly. You can always find a cheap maximum, because if you just make a box where the height is the highest point, this whole box has to be, the area of that box has to be greater than this right here. So is that a quick and dirty way to find a max? Sure. Is that a very accurate maximum? Not really. There's big gaps here, right? So there's probably better ways, but the idea is if you want to prove something, sometimes that's what you have to do. I could give you one of these and say, like, find it, and then what do? You look for the highest point, and then you make a box with the highest point. Kind of makes sense? Let's say I have a message, M, and I turn it into a numeric message, a number. I then think of I have a huge prime number that's secret to me, okay? I multiply it by my secret key, let's call it C, and I send it over to my friend. My friend gets it and has no way of factoring this huge number. My friend looks at it and goes, I have no idea what this is, so the friend gets it and goes, I can't read it. The friend has their own very big prime number that only their friend knows. What does the friend do? Multiplies it again. Sends it back to me. I look at it, right, and I get MCD. Do I have any? It's all multiplied together, right? What do?
Divide by MC.
I divide by C.
Oh.
And what do I send him? MD. And what can you get from that? M. The message. The point is, this is a really, really simple way of explaining some cryptographic methods. We didn't have to share anything to begin with. It's like this. I have a box. I lock the message in it, and I send it to you. You get a box that's locked. You have no way of opening it. So what do? You take your own lock, you put it on the box. So now you have a box with how many locks? 2. You send it back to me. Can anybody open the box? Not very easily, right? I get it. I can't even open it, but what's the one thing I can do?
You can unlock
I take my lock off, and then what do I do?
Send it
Put it back in the mail, and you get it, and what can you take off?
Lock.
The lock. Exactly. So I've just, without communicating to you, I've managed to send you a message that no one in the middle can read. Do you understand? To really just the integral from what to what?
0 to 1.
Of? Yeah, exactly. Wonderful. So then can you do that by hand? Yeah, what does that come out to be?
1.
1/10.
Oh yeah. Sorry.
1/10. Yeah, you go up power, blah blah blah. Okay, let's check it. So what did you wanted to factor out a 1 over n, correct? So you're looking to do limit as n goes to infinity of 1 over n. So if you could you factor out 1 over the square root of n pretty easily?
Yeah.
Yeah, so that would turn it into 1 over the square root of n plus 1 plus 1 over the square root of n plus 2 all the way up to 1 plus just n plus n. I'll leave it like that. That's fine. It's just a little easier to write out.
Okay.
But it's not. We need 1 over n, right?
Right.
So what do you multiply the top and the bottom by?
Square
Square root of n over the square root of n. So what does this become? The limit as n goes to infinity of 1 over n times what? Square root of n over square root of n plus 1 plus square root of n over square root of n plus 2 plus all the way to square root of n over n plus n. You with me so far? So let's combine some stuff. Limit as n goes to infinity of 1 over n times the square root of n over n plus 1, the square root of n over n plus 2 plus plus square root of n over n plus n of 1 over n bracket. How about this? What can you break this into? You can break it into, what can you do to these fractions is what I'm asking you right here. What could you do to those fractions? Any idea? Well, how about
How
this?
about you invert the whole thing?
No, I'm not going to invert the whole thing. I'm going to turn it into this.
As, like, n approaches 0, n times.
What did I do? What did I just do? So if you wanted to rewrite this, this is 0 to 1 of 1 plus x to the negative 1/2 dx, correct?
2 root 2 minus 2.
Do you get that? 2 root 2 minus 2?
Yeah.
Yeah, good job. Yeah. So it's 2 times root 2 minus 1, just factoring out the 2. Yeah, that's correct. Good job. There it is. Side, what do you have to use?
Product.
Yeah, the derivative of
First,
times
second,
the second plus the first times the
derivative of infinity.
cosine pi x times what? And what's that going to equal?
That's going to equal
F of
x squared.
times what?
2.
2x. Exactly. Exactly. Very good. Okay, so what do we want to isolate now?
Yeah,
What do we want to, oh yes, what do we want to isolate?
F of x squared.
F of x squared. So now you know that f of x squared is equal to sine of pi x plus x pi cosine pi x all over what?
2x.
2x. So if you want f of 4, what do you plug in for x?
2.
2. 2 or negative 2. So let's plug in 2. So we get sine of 2 pi plus 2 pi cosine 2 pi all over 4. What is sine of 2 pi? So you end up with 0 plus 2 pi. What's cosine of 2 pi?
Negative 1.
Cosine of 2 pi is
Oh wait.
1
Oh, yeah, sorry.
over 4. So what do you end up with?
Negative pi.
Pi over what? 2. There it is. That's a great problem. What did we use right here at the beginning? What theorem did we use to do this right here? To get this line? What theorem were we using?
Fundamental theorem.
FTC1. Right, exactly. We needed f of x first. In fact, we didn't really get f of x. What did we get? F of... So there's another tricky part. We got f of x squared. So if we plugged in 4, would we have been correct? No, we had to plug in 2. Because we had to square 2 first before we plug it into the function.
We would have found f of 16.
F of 16, exactly, and it would not have been correct, yeah. That's up. So we have to find f prime. So you know that f prime of x is going to be equal to 1 over the square root of 1 plus g of x cubed times g prime of x. So if we want to find f prime of pi over 2, we also need to find g prime, right? What's g prime going to be?
G prime is
1 plus sine of
cosine squared
cosine squared x times what?
Negative
Sine x, correct? So what do we plug in for g prime? G prime of pi over We're going to need g prime of pi over 2 because this g prime of pi over 2 has to go right there.
Yeah.
So if we plug that in, you end up with 1 plus sine of, what is cosine of pi over 2?
0.
So sine of 0 times negative sine of, what is sine of pi over 2?
1.
So it's just going to be negative
1.
1. What's sine of 0?
0.
So this is just 1 times what?
Negative 1.
Negative 1, so it's?
Negative 1.
So this negative 1 marches up and goes right there. Oh, right there. So then, you then also, but the challenge now though is you need to plug in values right there, correct?
Well, actually, scroll up.
Yeah.
G of x is from 0 to cosine x, cosine of pi over 2.
I got it. I'm just saying we have to deconstruct it.
Yeah.
At this point, you might freak out a little bit because you're like, man, I have to integrate like this thing, right? Well, no, you have it right there. Like you have a definition for g of x, right?
Right.
What is g of x? G of x is that integral.
Yeah.
So you know, g of pi over 2 is going to be the integral from 0 to, what is cosine of pi over 2?
0.
0 to 0 of, you don't
It
care,
doesn't matter.
right? Because what's that going to be?
0.
0. So you know that this right here, where's that going? Right there.
So it's 0.
0 cubed. So what do you end up with?
Negative 1 over square root.
Negative 1 over the square root of 1, which is
Negative 1.
done. This one collapses really nicely.
Yeah.
Rather negative.